Hi, hello. Welcome to my channel. It's MathSciTech. That means mathematics, science, and technology. And today I'm going to make a video on functions. So yesterday I have given the uh, overview of mathematics from school to college. What are the topics that we are learning step by step? And today I will be precisely explaining the functions. Let me take you to the function. I would like to write function, and this function actually you can represent in many ways, like you can say that verbally you can represent, and you can represent graphically or numerically, algebraically. Let's say that verbally you can, verbal definition you can write it, that is verbal representation. Next one is numerical or the tabular form, numerical or tabular form, or you can represent using algebraic form or concise, precise definition of mathematically you can write it, and then you can represent graphically, graphical representation you can use. Next one is then you can use mapping diagram also. The other way is that mapping diagram, that is mapping diagram. So, this many ways you can represent a function. See, the verbally, if you want to define, you say that you are actually assigning value. That means there is an input, there is an output. So, you say that you are assigning actually the function is actually a rule that assigns for each element in the domain, that is x belongs to A, where A is my domain, and it assigns the value f of x, that is in codomain B. This is codomain B. So, for each element in A, that assigns a value in B. Suppose in other words we can say that each input, each input must give one output. One output only. So, this is more important here. So, it should not give one input, should not have multiple outputs. That is, let us say that you substitute f of 1 must give you one of the value. Let us say 5 is 5. It should not give you 5, 6, 7 different outputs. Therefore, it assigns each value of input exactly one output. Otherwise, we have to recall it a relation, where relations is actually more generalized one, relations where you can have, one input can have more outputs also in relations. That is why we call it relations are more general than functions. Always you can say that functions function set is subset of the relation set. You can say that in set notations. Let me take you, or write in different way. We also further write it, this is the input, and then the something like that you are feeding, and there is a mechanism here, and that gives you output f of x. This is the output. So, we can represent this way. This is how the function is actually working. This is the function property. Based on that, the output will be given, f of x will be given. And after this definition, you can see that tabular form, domain and codomain, if you want to define it using a diagram. Let us say that this is A, and there are elements, some elements are there, and then it need not to be more less elements in B, less elements can be more in B, it does not matter. So, but all elements in A must be having one connection in the set B, that is the codomain. So, let us say that this is B codomain, this is the domain, and you see, you can say that it need not to be different. There are scenarios where you can map all inputs to exactly one output. We call it constant function. we are actually labeling it. I mean, we are redefining it, what is a constant function and all those things. That means all inputs, A is whatever the inputs are there, the outputs must be, B is codomain, right? Codomain. Therefore, this is domain. And there are scenarios something like this. You see here. So, all are mapped to one particular element. We call it constant function. This is a specific constant function. And of course, once you understand what is a function, you can see the types of functions and all those things. This is diagram form way of representing these functions. The other one is that tabular form, where in the tabular form we call it x and then f of x. So, there is a table for it. So, based on the functions form, it is giving outputs. Suppose you can say that 2 to 4, 3 to 9, and then 4 to 16, and then 5 to 25. This is how it is working, like f of x equal to x square function. The inputs are in the form of x. These are the inputs. These are the outputs. These are the outputs. So, that is, it is like, it is whatever the input you are giving, input is in the form of x, the output is in the form of x square. This is the output. This is input. Input is transformed into x square form. So, this is how we are representing tabular forms. And then you have the other form is that algebraic form. The algebraic form is that let us say that f of x equal to x square, if you want to call the previous example, that is previous tabular form example. So, I mean, we have to recall them and then see the all possible forms of this functions, and we have seen that how to represent numerically, verbally we have seen, algebraic form we have seen, and mapping we have seen, that is I have referred as a diagram. And then another one is that graphical representation. Mapping is this is actually representation of a mapping. This is mapping that is representing a function using mapping with the help of mapping. So, this is how we are representing. And then last one is that the algebraic form also I have given that is the mathematical expression we are using to represent any function. So, this is one such. And now after this is the mathematical form or the algebraic form. We use it. It is the expression you are expressing it precisely in a shorter form. So, here there are advantages and disadvantages. I will recall them all in 1 or 2 minutes. Let me take you to the another form is that graphical form. So, graphical form, if you look at the same example, f of x equal to x square, and that is so you see that x is f of x equal to x square, because I have recalled that x square example in the earlier case. Therefore, you see that when x is 0, the output is 0 when x is 0. So, in other words, you try to understand from the table. So, when x is 0, input is 0, f of x is 0, because 0 square is 0. Therefore, you are representing here. When x equal to 1, f of x is equal to 1 square, that is 1. Therefore, x equal to 1 is some unit here, and then output is on the vertical axis. Therefore, vertical axis somewhere here. Therefore, the coordinate is something like this. And then f of minus 1 is equal to minus 1 whole square, that is 1. That is x equal to minus 1. The output is minus 1 whole square. Therefore, x equal to minus 1 is somewhere here. The output is in the same height. And then look at that x equal to 2 location. F of 2 is equal to 2 square is 4. Therefore, 2, 3, 4 vertically. Then this is the horizontally, it is 2, 1, 0. Therefore, it must be somewhere here. So, and then similarly minus 2. f of minus 2 x equal to minus 2, f of minus 2 is equal to minus 2 whole square is 4. Therefore, it is 4 in the positive direction. Therefore, I have to represent here somewhere here, and now you try to connect all these points, you will be getting a parabola. This is the graphical way. See, there are advantages and disadvantages. You look at this, I mean, graphical way is that you can see a nice diagram, what is happening, what are the, how this is shape is looking like, all those information you can get it. Further, you can say that it is moving up or down. All those information you can get it by looking at the graphical form. Further, you can assess it or you can predict this. But if you look at the mathematical form, that is f of x equal to x square, this is mathematically concise and a small expression form. Unless you work out, you don't get anything, but it is the best way to represent in a shorthand notation. I mean, it is a simpler form. The other one is the tabular form. Tabular form will give you some information about it, but always this is not I mean simpler way to observe this data unless you point it out in the graphical form or writing in the function form. You suppose you want to find it what is f of 100, unless you express that f of x equal to x square structure, it is following, finding that 100 input output, the corresponding 100 output is difficult here because we don't know the structure. Therefore, but here if you say that x equal to 100, you can immediately say that this is 100 square. Therefore, that is the handy, actually having mathematical expressions is always handy. Therefore, we can easily assess or identify the or can fill the gaps in between any value you want. You can do it. That is the advantage with the mathematical expression. But the tabular form is also useful. There are scenarios where we need the tabular form to get those particular values, or kind of you in the future you can see that where data may be in the tabular form, you want to fit some polynomial, where shorthand notation, mathematical expression you want to fit it, you are going to fit it, because in mostly the real world problems are something like that in the discrete only. It won't be like a exact function form. Therefore, to handle the data, we are actually learning this tabular form also, and then slowly we will relate it in the future classes, how this, why these tabular forms are important, because you take anything because of many constraints. Let's say if you want to record it the temperature in every second. So, storing the data is very difficult, and you don't see that much differences in second wise. Therefore, we are going for time interval maybe 30 minutes, 20 minutes. This is kind of difference is the time gap is huge, and then you are storing the data, and then to that is there any specific function you can fit it, to analyze it, and then for tomorrow and all those things we are using these functions. And similarly, you can see that patients data and all those things, that is useful for future predictions of any disease or something else that we will see later. But this is I mean overview to understand this. This is the mapping is easy to understand. That is why we use it to visualize it, how a function can be defined, what is meaning of a function. This is another way, I mean easiest way to understand that. That is the reason we are using this domain and then codomain, and then there are connections you are trying to show it. And then this is verbally I have defined, I told you it is for each input you are assigning. Function is like a machine, it is assigning a value in the form of a output. So, this is how we are actually trying to understand the functions. Once you understand the function, handling any other is easy to follow actually. Once you understand the function, it is easy to follow. Let us say that a few examples, you can say that demand function or the cost function or the other functions are the production function. All these are the function examples where you can see that functions are having different types. Let us say that it is continuous function, discontinuous functions, and then differentiable functions, non-differentiable functions. We can take it, it is a vast one. I mean, you cannot close it this topic immediately. But however, whatever you need the basic information I have provided in this video. And for example, you take f of x equal to 1 by x minus 3. So, this function is well defined. I mean, Whatever the functions I am recalling, that is mostly on the real domain only. That means the all inputs are the real values only, real numbers only. Therefore, this function is well defined everywhere, well defined everywhere except at x equal to 3. When x equal to 3, this is of the form 1 by 3 minus 3, 1 by 0, undefined at x equal to 0. Therefore, we are saying that its domain is excluded. That means you can say that r minus singleton 3, sorry, not 0, r minus singleton 3, where this function is not defined. And another example is g of t, you take it square root of t minus 2. This function is also well defined for all t greater than or equal to 2, because if you get when t is equal to 1, that is 1 minus 2, that is equal to minus 1, which is complex number. So, we are generally excluding it, Our main focus is only real domains. Therefore, I mean the domain that can give you the proper number and also part of the real numbers. So, domain and then codomain, both are actually, we are restricted ourselves to the real numbers only. That is why we are defining in this way that t must be greater than or equal to 2 to validate that data. So, therefore, there are many things you can say that suppose you take the tuition fees are in a academic year or kind of population in the year wise or the decade wise, and you see that nicely inputs, you can see whether it is increasing or decreasing, and then you can assess all these informations, and you can further see, I mean I told you like cost function, profit functions, or the supply functions, revenue functions, and all those are part of the functions. So, with this I would like to stop.